In Unit 2, our goal is to focus on statistical techniques that are used for visualizing insights contained in our data and also methods of summarizing or condensing data in a form that humans can relate to. How do we get about that? So let us begin on page 2 of our notes. And here, our first goal is to learn how to summarize one categorical variable using frequency distributions. You see, we can summarize a categorical variable by counting the number of cases in each category of a categorical variable, sometimes expressing the result in a tabular format, otherwise called a frequency distribution. Now, you see, to illustrate what a frequency distribution is, I would rather say it's a fancy name for a table that is a summary table. Let's take an example here where we have collected data relating to polls, and that is with regard to Super Bowl, which is the championship game of the NFL. It's an important social event for Americans with tens of millions of viewers. Now, polls were conducted to check whether respondents were more interested in the game during the Super Bowl or the commercials. Here are 40 responses from one such poll, and our interest here is to see if what the distribution of the different responses are. So our goal is to construct a frequency and a relative frequency distribution. What that entails is to look at the different categories of responses. Say, for example, some people watch the Super Bowl for the commercials. Well, go back to the raw data, and our goal is to summarize that raw data using a frequency distribution. We would count how frequently does the response commercials pop up in our data set. If you count through this, you'll be able to count 8 times when commercials pops up. So we record that as 8. For game, it is 18. For won't watch, 12. And those who don't know, that is 2. That gives us a total of 40 responses. For the 40 responses, we're going to obtain the relative frequencies by doing a little comparison. For commercials, you have 8 out of 40. That will be written as 8 out of 40, which in decimal form is the same as 0.20, which means 20% of the responses said, or 20% of the respondents watched the Super Bowl because of the commercials. Similarly, for game, it is 18 over 40, which is 0.45. And then for won't watch, 12 over 40, that is equal to 0.30. And lastly, you have 2 over 40, which is equal to 0.05. So, looking at this summary table, otherwise called a frequency or relative frequency distribution table, how would you report your insights in the original data? Well, we could say that a majority of those who watch the Super Bowl watch because of the game, followed by those who won't watch, as far as that data set is concerned. That would be one way to report our findings in the survey. Now I have completed this manually. Can we complete this using technology? I have provided um, data set called Unit 2 data set. You will be able to find that in your Blackboard course shell or in the folder for the week. And to load that, after downloading it on your computer, you go to data, you go to load, and I'd like to load the data set from my computer. So I would click on this on browse, and here I'll be able to go to unit 2 data sets. So load that, then indicate that you want the first line to be a column name. So upload that, and that should pop up in a new screen. In the first column here, I have all the responses, and I would like to use StatCrunch to generate the frequency and relative frequency distribution table. To do that, I will go to Stat, and um, I'll go to Tables, and I'll go to Frequency. Click on Frequency. Let me take that back. Let me get out of here. Let's go back. Let's do that one more time. Go to Tables, go to Frequency, click on Frequency. We want all the data points under responses, so I'll choose responses and indicate that I want both the frequency, and to do a multi-selection, hold down the Control key to choose relative frequency and compute, and it returns the frequency and relative frequency table. And with this, we can readily say that a majority watch the Super Bowl because of the game, followed by those who won't watch. So technology can be very, very useful, especially when you have an extremely large data set in making this count in an accurate manner. Let's go back to our notes. So sometimes beyond tabular representation, we might be interested in representing the insights in our data for one categorical variable using pictures. The appropriate picture or graph to use is either a bar or a pie chart or graph. So we display categorical data in each of these charts or graphs using what is called the area principle. And the area principle indicates that the area occupied by a part of the graph should correspond to the magnitude or size of the value it represents. In particular, bar plots can be used to show the counts or frequencies or even percentages for the values or categories of one variable which may not necessarily be parts of a whole, whereas pie charts are particularly very useful in showing how a whole quantity divides into subcategories represented by wedges of a circle whose area corresponds to the proportion in each category. So here's an example of a pie chart, and here's an example of a bar plot. We can readily tell that based on the area principle, that mortgage takes what? The greatest area in this pie, in this circle, indicates that a majority of the responses here pertain to mortgage. That's what the area principle is saying. So pie charts are very useful for giving a high level overview, to show how a set of cases break down. 1, 2, 3 in this case. But as the number of subcategories gets increasingly larger, pie charts can be a little bit more difficult to read. So it is also difficult to understand details in a pie chart when you have too many categories. In this case, it is not really bad because we only have 3 categories. But as the number of categories becomes larger, the sizes of the wedges become increasingly smaller, and drawing a relative comparison at that, becomes a little bit difficult for the human eye. So while pie charts can be useful, we usually prefer bar plots, which can be registered vertically, as in this case, or horizontally, if you have something that looks somewhat of this look.